Let's go deep on just one thing: the robot's brain. The brain is a single neural network called a Vision Language Action Model, or VLA. Its job sounds simple, but it is brutally hard. It looks at camera images. It reads a language instruction like pick up the cup, and it must output continuous motor commands many times every second, forever. Pixels and words go in, smooth motion comes out. For the next few minutes, that is the only thing we care about. The key idea behind modern robot brains comes from psychology. Daniel Kahneman described two modes of thinking. System 2 is slow, deliberate reasoning. System 1 is fast, automatic reaction. Groot N1, an open foundation model from NVIDIA, builds the robot brain exactly this way. System 2 is a vision language model that looks at the scene and figures out what the task means. System 1 is a fast action network that turns that understanding into fluid motion. They are two networks, tightly coupled and trained together end to end. System 2 is the slow thinker. It is a pre-trained vision language model, the same kind that can describe a photo or answer a question about an image. Why start there? Because it has already seen millions of images and sentences from the web. It already knows what a cup is, what yellow means, what on top of means. The robot inherits all of that common sense for free. It runs at about 10 times per second, reading the camera and the instruction, and produces a compact set of tokens that summarize what to do. System 1 is the fast doer. It is a diffusion transformer. Instead of predicting one single action, it starts from random noise and gradually refines it into a smooth chunk of future motion, using a technique called flow matching. It cross-attends to the tokens coming from System 2, so every motion is grounded in what the slow thinker understood, and it runs fast, around 120 times per second, closing the loop with the body in real time. Slow thinking sets the goal. Fast thinking moves the joints. Here is a beautiful part. The same brain, the same single set of weights can control a tabletop arm, a two-armed robot, or a full humanoid. Different bodies have different numbers of joints and sensors, so System 1 uses small body-specific encoders and decoders, one adapter per body, while the core stays shared. The hard-won understanding is learned once and reused across every machine. This is called cross-embodiment, and it is how one model scales to many robots. Now the real problem. There is no internet of robot data. Teleoperating a real humanoid is slow and expensive, so that data is tiny. The solution is a data pyramid. At the broad base sit web images and human videos, enormous, cheap, full of how the world works. In the middle, synthetic data from simulation. At the narrow top, the precious real robot trajectories. But human videos have no motor actions attached. So they train a latent action code and an inverse dynamics model to guess the missing actions and treat each video as just another body. Cheap data teaches broad priors. Expensive data grounds it in the real robot. So that is the robot brain, end to end. A slow vision language model that understands, a fast diffusion network that acts, joined into one model shared across many bodies, and trained on a pyramid, from cheap human video up to scarce real robot data. Notice what is missing. There are no handwritten rules anywhere. The brain learns the entire map, from pixels and words, all the way to motion. That is the whole idea, and everything else in robotics is built to feed it.